record your name or your question accurately. So please go to the Etherpad. We can all contribute. Here's a blue sheet being passed down. So hopefully people can start filling them out. Agenda. Here's the milestone, okay? We have adopted quite a few working group drafts, and our working group, the primary goal is to define the data models to network security functions, and we have achieved quite a lot. There are quite a few. There's some leftover work, and AD wanted us to finish them as quickly as possible. By next February, we should all finish the data model and send to the IESG for review. And after that, we can either close the working group, or if there are new work, we can recharter and continue. Okay. So today's agenda. It's quite tight. So next one, I will pass it to the hackathon update. Okay. Yes. Oh, yeah. Sorry, I have to. Okay, do this. Sorry. It's working. Sorry. There's a bit technical issues. I think this is the button too. Okay. Sorry. Okay. Go ahead. This one. That's that. Okay.
This is the present role, and I report for I2NSF framework project and IETF 102nd. We implemented the I2NSF framework using open source software. This work involves 7 graduate students in Sungkyunkwan University and 2 graduate students in Sungsil University. 3 professors and 3 researchers are leading our project. This is the poster for I2NSF framework project. In this hackathon, we implemented the registration interface, security policy translation, and automatic policy provisioning. First, the registration interface. I2NSF user requests NSF capabilities to security controller. Security controller translate the high-level policy into low-level policy. If the security controller could not find the proper NSF, security controller requests the instantiation of NSF to developers management system. And then developers management system register the NSF to security controller. And this is the young data model of a registration interface. And this is the step of security policy translation. First, extract the data from high-level policy using the extractor, deterministic finite automata, and convert the data into NSF required data. and then make low-level policy using the context-free grammar. The top of tree is the NSF required data and matching the capabilities using context-free grammar. So left blue box is the left blue box is the example of making the low-level policy for firewall, and right blue box is the example of making low-level policy for web filter. This is the hackathon topology, and this is the this is implementing environment. We uploaded our source code at GitHub, and you can see the demo and YouTube. In this 100-second hackathon, we implemented the registration interface, security policy translator, and automatic policy provisioning using the CompD, JConf, Suricata, Open Daylight, and Mininet. Thank you.
Thank you. Thank you very much for doing the hackathon. And we'll move on to the next one. So this next one is on the SDN-controlled IPsec configurations. So the presenter will be talking remotely afterwards, since there's another model. In this particular model, they define two cases. Like one's the controller only sending down the configuration. Another one is element network service function security function doesn't support IKEY. And actually there's a third model. So after this presentation, I'll let Carol to talk about the third model and then see how that could be maybe integrated together. Okay, so
Okay.
Okay.
Can you hear me?
Yeah, we can hear you.
Okay, thank you. Good afternoon there. Basically, following Chair's advice, we have created this presentation trying to summarize what we have done, the idea behind our ID, and some future steps. So what is the next slide? Sorry. So basically what we are trying to define is an architecture for the management of IPsec security association using an SDN model. So we have a centralized controller providing the information to establish dynamically all these IPsec security association. We define two cases. In the first case, the assumption is the network security function will have an IKE version 2 implementation. So the controller will need to configure that implementation and other pieces of different databases related with IPsec. And then the case 2, where the assumption is the network security function doesn't have any IKE version 2 implementation. So the only thing we have is the kernel support for IPsec. So the goal behind the draft is to define the NSF-facing interfaces required to manage and monitor all the IPsec security association in NSF, taking into account these two cases, case 1 and case 2. For case 1, we will need a JAM model for IKE version 2, SPD, PAD, and models that allow us to collect state data for IKE version 2 and the SAID for the IPsec security associations. Of course, in the case 2, we don't have IKE, we don't need PAD. The only thing we need to define there is the SPD and the SAID. And actually, our graph already has the JAM models for all these cases and all these required information. So next one. So here, just a summary. You can find the explanation in the internet draft. Case 1, as you can see, NSF has the IC and IBSEC support. So the controller will need to provide that information based on the jump model we have defined. The case 2, there is no key management protocol in NSF. So NSF is simpler somehow. So the security controller, following the typical SDN paradigm, the controller has control of everything. So it needs to create all the state, it needs to create the IBSEC security associations, because actually the NSF doesn't have an IC implementation, IC version 2 implementation. Next one. So as I mentioned, we have already defined the jump model. The model is based on our reading, our understanding, our experience, and the RFC 4301 and the IC version 2 RFC. And we have also included some information observed in some implementation out there, in particular XFRM API in Linux system. And as I said, depending on the case, you will need to configure part of this model. For case 1, you need IC version 2 information, PID information, SPD for the IBSEC policies, and actually related with the IBSEC Security Association, the only thing you need is to get or collect state data, because after all, IC version 2 will create that IBSEC Security Association for you, based on the information on the SPD and the rest of the information. In case 2, there is no IC version 2 implementation. So the only thing we need to deal with is SPD to include IBSEC policies and collect some state data, and then to create, to configure, and to collect state data about the IBSEC security associations that the controller has created based on the information provided by the administrator, using typically the northbound API. So next one. So we have some updates from the last version. We provided the last IDF. We didn't have any presentation because it was a minor modification, but right now we have a new update in section 5.3 in the discussion about case 1 versus case 2, where we describe a little bit the regain process. But now in more details, we have several steps there, like an algorithm explaining how to do it in case 2, or what happened with the NSF crashes, for example, and then it doesn't have any state about the IBSEC, or what happened in the natural vessel behavior. We have also added some state data to Jan model. For example, to collect current IBSEC SA lifetime or current policy lifetime, or what are the numbers of child SAs that the IC version 2 implementation has dealt with. So basically that, and then that is pretty new in this new version 0.2. Next one. So here are a few slides about it's the next one. It's the not traversal, this is update, next one, not traversal, okay. So the configuration for not traversal is, in case 1, basically is fairly easy, because the only thing you need to, IC version 2 is in the NSF and has a mechanism to detect not traversal, so little configuration there. In case 2, it relates on the assumption that the security controller knows the network it controls and can now discover where the network devices are not configured. Based on that, the security controller needs to establish, for example, ESP over UDP or ESP over TCP, etc. And we have that information in the Jam model. Next one. About the RIGI. Again, case 1, of course, case 1, we have IC version 2. IC version 2 already handles the RIGI part, based on the lifetime associated in each IBSEC SA. But when we don't have that, and everything is shipped to the security controller, we need some kind of procedure to do the RIGI. Actually, what we have designed is something simple, in the sense what we do, in summary, is the security controller will create the inbound security association in both NSFs, in both, and that RIGI will start when we receive a notification from the NSF, one of the NSF, maybe both, saying some particular IPsec security association is going to expire or is expiring. And then we create the inbound security association first. When we have confirmation the inbound security association are there, and then we install the outbound security associations. And then in that part, after that, we can remove the old IPsec security association. Of course, we can think about another approaches, maybe more optimized, but this one could be reasonable in the sense everything is fixed in terms of the installing inbound and then outbound, and then when everything is set up and it's okay, and then we can remove the old ones. In case, for example, one of the NSS crashes and lost the state, actually the algorithm for the case 2 is fairly similar, except in the step 3, where obviously, for example, in one of the NSF is B, if B crashes, then there is no need to remove the old IPsec security associations, but we need to remove the other peer, the old other peer security associations. Next one. So regarding the implementation we have, actually we have NSF implementation. For case 1, we have the IKE version 2 based on Strong's one. And regarding to the netconf and Jan implementation, we're using NetUbir. This is a Linux-based implementation. For case 2, we are just using NetUbir, no need for IKE version 2 implementation. And we have been able to provide basic configuration about establishing this IPsec security association, but just using a netconf client, using the terminal from another machine. So what we need is to work in the security controller side. We have explored ODL, Open Daylight, and ONOS. We have been able to configure NSF in a very basic mode using both controllers. We have ODL and ONOS, but I can assure you we still need a lot of work there. As you know, this piece of software are complex, so we are fighting with them at this point. Our goal, actually, we would like to have a complete proof of concept, at least an autonomous way to receiving notification, what happened with one NSF is crashing, or during the recap period. So we are working on that. So that is part or related with the next slide. Please, next. So to be done, of course, what we need is review the jam model in the current state. We have detected some minor correction that we will update in the next revision. But we received Paul Bauder's review some time ago. But of course, we have received that, but we require more reviews from expert, of course. And on implementation level, it's clear we need to continue the work in the controller side. We would like to have a complete and autonomous scenario, at least, even if it's small, at least to see how everything evolves based on all the notification we have designed, on all the information we have, the jam model, etc. And we would really appreciate collaboration in this side, because I'm pretty sure there are more experts in the room and out there that are working with implementation. We have seen them in the hackathon, and we would need some help on this part. So that is my presentation. I have tried to be short just to promote some discussion. If you have any question, just let me know. Thank you.
Thank you. Any questions, comments?
Frank Xia, Huawei. Hello. Firstly, I want to say that I think that is a good draft because it is a proposed valuable solution for the industry. right now. For example, for the SDN management and provision, we need this kind of automatic IPsec VPN kernel construction solution. So this document is a very good input. For second comment is, I think during our previous discussion, whether it's by main list or by some offline discussion, I think the biggest question or biggest concern of current draft is mainly on the case 2, on the how to directory configure or manage the session key and the related session session attributes directly to the CPE to the peer. So actually I think your case 2 solution is one way, but there are still other way based on the SDN control, the centralized way to, for example, where we can calculate the key and how we distribute them. So, but I kind of think this has some trade-off between the security and the provision efficiency or the scalability. So I would like to hear more discussion and comments on this part. Should we support multiple ways to provision them, and how to say? I think at least from my personal view, I think the case 2 solution has its own value and its own scenarios. But we must have a good assumption that the controller and the manager link between the controller and the peer has a well protected method to protect the information exchanged then. So that I still think that the case 2 method is valuable. It makes sense. So that's my personal idea, but I think we don't have get the consensus about it. So I'd very like to hear more comments about this point.
I have the main. Thank you. The main part there is one of the key questions there was. Obviously, the SDN controller, the security controller, needs to create all the IPsec security association in the NSF. That's clear. And one of the parameters, of course, is the key you will have to use. And that's the particular comment there. So the concern might be, okay, the security controller is seeing at some point, is in the keys that will be installed in the NSF. The question is, obviously, following the SDN paradigm, the controller should be a trusted entity. Obviously, you have security associations between the NSF and the security controller based, for example, if you're using netconf, you have TLS or SSH. So the distribution itself is not the problem. The problem or the comments we have received is the security controller will need to create a random key that we finally be installed. It will be finally installed in the NSF. That's the key point. So solutions, there are a recent draft as well that written by Dave Carroll, where they want to avoid that, for example, using some kind of Diffie-Hellman, saying, okay, the controller doesn't see the key, so the key is generated by the NSF itself. So the security controller cannot get those keys from anywhere, right? It creates maybe some problem, but that's another discussion. The thing is, the key point in case 2 is what happened is somehow the security controller is not trusted for some reason. It's attacked, and then what happened?
Thank you. You have a comment? Can you just speaking now, or do I need to do anything here? Like this?
Hi. Thanks for bringing this, and I've got two questions. Well, the first is, well, I still don't see the value in your case two, because any NSF is running on some platform, could be usually Linux, could be Mac OS, could be Windows, even phones. Every one of them has an IKV2 daemon. IKV2 daemons are ubiquitous. They're as ubiquitous as TLS implementations. So they're everywhere. We don't really have this poor NSF that doesn't have an IKV2 implementation. And the other thing is that, well, it's a matter of key hygiene. We know the saying that 3 people can keep a secret if one of them's dead. So it's far better for the traffic key, at least, to be common just to the 2 peers and not be able to, and not have the SDN controller being able to leak it. And well, one final thing, that's for Linda. We really need the JavaScript. So, well,
All right, okay.
Is anybody can do JavaScript? So right now we don't have anybody who can do it. My computer cannot allow that. So, Brian?
Yeah, quick question or quick comment to the presenter. This is Brian Wise from Cisco. I think the contribution of the Yang models is very valuable, and case 1 is very valuable as well. Just to put what maybe you all have said in a different light, or what some people have been saying, when we think of distributing configuration through a Yang model, that's reasonably safe because a third party that would see the configuration can't do a tremendous amount with it. But when we treat keys as configuration, that's where the threat model becomes very difficult to deal with. And I think that's what another way to say what's kind of the issues with case 2. Thank you.
The thing, can I say something? Okay. The thing is, in our view, in our experience, for example, when the SDN paradigm started, for example, the routing protocols are not in the routing device, so are moved to the to the SDN, and basically the routing device is just merely switch processing flows. So that's the basic idea on case 2, right? If you are doing that, you are moving part of the control to the part of everything, and just leaving in the device the flow-based part, which is the IPsec kernel, for example. What I have seen regarding your comment, Joab, I don't understand why NSF should be. Is there any requirement for an NSF? Should be this one or this one or this requirements in terms of CPU, memory, or everything? I don't know. Here we have seen some comments also in the mailing list saying maybe we can have, for example, thousands of nodes creating, and then if you're saving some memory or some CPU, could be variable. So what I see is, obviously, if you have a constrained device, there is a valuable thing there. Are we saying this word is not valid in general? I mean, in this working group to to provide that kind of models to more constrained devices to save memory, save CPU? I cannot tell. I'm working also with IoT stuff, and then some of these ideas are coming from there. Maybe you are not using IPsec, maybe you're using DTLS or DTLS, but I don't know. What are the NSF requirements in terms of capacity or capabilities that NSF should have in that case?
I remember during our intro meeting on this subject, we agreed that this document should clearly writing down the security risks associated with Model 2, right? So that for like IoT device with a very constrained resource, they can utilize that with acknowledge the risk they are taking. I thought that was the agreement.
Right. In fact, the ID has a security section explaining precisely that, in the sense, okay, of course, you have a trusted entity which is acting in a key distribution center. Obviously, if that trusted entity is not trusted anymore for some reason, then that's clear. But I think it's, as you mentioned, it's a trade-off. Somebody, I think Frank mentioned that. It's a trade-off. Obviously, the NSF is simpler. Even in terms of implementation, you need to deal with just with the SPD jam model part, and the SID, just sending that information. And it's simpler. You need to deal with the kernel part and just that. Then in case one, then you need to add the information for the VAD, the IEC version 2 information, the SPD, of course, and SID just collecting data. But you know, what we see is there is value even in the case 2. Of course, there is a risk. It's there, it's plain, and it's somehow people understand that case and are trying to, you know, fixing that problem where, or that issue where maybe the controller may see some keys. Okay, that's good. That's good.
Yeah, well, I understand that. It's just that I personally don't see the case for IoT devices that do IPsec. Well, they might do it for themselves, but not in functioning as a network security function. And at any rate, I think this debate is going to continue at the IPsec e-working group later this day. So, yeah, we'll see you there.
Okay, so just to continue discussion, that there's actually 1.5 case, like between case 1 and case 2. So I'll let Dave and Carol to elaborate a little bit so that see if that kind of thing can be incorporated into those data models.
Okay, I'll try to do this really quickly. So we've, I work in a SD-WAN company. We were actually acquired by someone bigger. So I've been working on this problem for a while, and we have a real case where we actually do want something case 2-like. We don't want to implement an IEC v2 in our end nodes, but we need the security. You know, as Brian said, as Yoav said, there's key hygiene, and we don't want the NSF, or we don't want the central controller knowing these keys. So we put together this controller IEC, and whether it's a case 2 or a case 3, I don't know. It doesn't really matter. There may be, as Rafa was saying, there may be a point where you want a really a small IoT device that doesn't do any key management. So what we put together is really a simple idea. Can we pop to that first slide? So what is this controller IEC? It's a key exchange method, and that's really all it is. We're not trying to create a protocol that manages the NSF. This is something that would be suitable for embedding in Rafa's submission or something else. The concept is really simple. We're doing Diffie-Hellman. So each peer creates their own Diffie-Hellman pair. They're going to send their public values up to the controller. The controller will distribute out an entire list of everybody's public keys. And now every node can create a shared secret with every other node in the network. It's pretty simple. There's no peer-to-peer messaging needed. And you know, speaking to Yoav's comments, this is part of where the value is. We don't want peer-to-peer messages because we have topologies where there's possibly only one-way communication. We have topologies where we don't want the latency of doing an IEC setup. And you know, I think people have talked on the list about how many RSAs can you do in a second, but there's a little more to it than that. So anyways, if you look at it, that's all we did. Now we've got our keying up. It sounds like that was really easy, and now we're done. But the problem is synchronizing. So we have to rekey all these devices fairly often, right? Keys get stale. We don't want to use these keys forever. So what happens when one peer rekeys? They're going to send a new key up to the controller. The controller now has to distribute that to the other peers. They're all going to get it at a different period in time. And so keeping this all synchronized is an issue. It's something you have to worry about. When you've got a network of 10,000 nodes, you can assume that a lot of them are rekeying at the same time. So now you have to handle how does all that happen, and we don't want to drop packets. Can we flip? So synchronization is where it comes down to. I'm going to speak a little more to this in IPsec.me, so I'll be really quick. In the draft, we've got 4 rules that you have to follow. We've spent a lot of time kind of proving this out and reducing it down to 4 simple rules. If we follow those, we have state machines that now can support all of this synchronization in very large networks, even with, in our case, it's tens of thousands of nodes. And it all works. Everything can be done simultaneously if it needs to, but the synchronization is very loose. So one person can rekey at one point in time, another peer can receive those keys at a later point in time. In fact, they can receive those keys and decide, I don't have the time to deal with it right now, and I'll react to it later. It's loose, it all works, everything comes out. Security needs, the big thing in this, only the peers know session keys that are being used. And that was pretty much the impetus for this. And that's all. I'd say read the draft and find out more. Come to IPsec.me, and we'll have more of a discussion.
I do have one question.
Yes.
For the messaging between the nodes to the controller, what carry the message? Is it like a...
So we don't define a protocol. It's a
Okay.
method. So we've indicated what needs to be in that message. What are the fundamental units? But I'm assuming that an I2NSF protocol or somebody else's protocol is what's going to be carrying this.
Okay.
And there are requirements on there. You need to have a trusted, authenticated connection to your controller. If you don't trust your connection to your controller, all bets are off. This would be pointless.
Thank you.
I have a question.
Yeah.
Yes, basically, the thing is, assuming we are using Diffie-Hellman, of course, if the SDN controller is attacked, then we may have a man in the middle, possibly man in the middle, but obviously this is better because in the end, you don't see the keys, the final keys. But I'm thinking that, for example, looking at the case 2 we have, where we send all the IPsec Security Association information, instead of sending the key, you could send, for example, the public key, the Diffie-Hellman public key, right?
Correct. That's
So
what
in the end, what we are, we are keeping the same. There are maybe a little something we need to change, but what I see is if I send that information, this is the IPsec Security Association I want you to configure, but instead of sending you the key that I generated, I meaning security controller, I'm sending you the public key of the other side.
Correct. So yes, the SA information, it's pretty much all of it would still be coming from your protocol, but not the keys. We want the key to be something that only the peers know.
So that's fine, because in the end, there's still, to me, I think your presentation is saying that, and I agree. Is case 2 is I don't say case 3, or what I see is case 2, but with the modification that instead of sending the raw public key, the raw session key, you're sending the public key, so the NSF is generating the.
Correct. And we need to add a mechanism for the peer to send its public key up to the controller.
But you get, there are ways to do that.
That's fine. I would assume that it would be part of this, of your draft, or no, but yes, it needs to be provided for. How that's done.
So actually,
yes.
Sorry, this is Kent Leong. Actually, I just want to break the tie here, right? I think there's a distinction what's being mentioned, right? So I think the way Raphael's mentioning is that it's similar to the scheme that you guys proposed, but that in the sense this controller is the man in the middle, aspect, right? So I think that's what Raphael's saying, that the method is using your Diffie-Hellman, but then it's generated by the controller versus having one side generating it and passing it through the controller. That's my understanding the difference.
Then I may have misunderstood.
Is that right?
Yes.
That's what I seem to hear.
Are you
Is that
talking
right?
about the controller generating the public keys?
No.
Okay.
The state machine could be like.
Two questions. First one, through your method, what you achieved is you calculated the pairwise session key among each pair of pair, right?
Correct.
Like the classical IKE version 2, right?
Correct.
Okay, and okay, this is one question for clarification. Secondly, in addition to the session key, how about the SA attributes, other SA attributes? Do you share the same attributes among all the communication peers, or still the pairwise?
So SA attributes aren't specifically a part of what our method. Our method is really focused on just getting the keys across. So I would assume it's still up to Rafa's protocol to push down the SA attributes and tell the NSF how it's supposed to be communicating. In our method, we added some ability for, you could almost call it negotiation. When you have cases, typically in an SDN network, you've just told everyone, you're running AES GCM 256, period. And nobody has to negotiate anything. But there are times where you'll be doing migrations. You may be moving to, from AES 128 to AES 256, and you don't want a red letter day where traffic's going to stop. You're going to want to tell people to migrate. And so how do you then have people figure out, when there is no IKE between them, that, hey, I can only do this, but I can only do AES 128, but I can do 256. So we tried to put in some provisions for that, but it's potentially not necessary.
Okay, so if I understand you correctly, so your here you just do the key negotiation, but other attributes maybe not negotiation, right? It's a centralized way and tell everyone the same SA attributes something. Maybe we can talk offline. Sorry.
Correct. Yeah.
Yeah. Okay.
Okay, Brian Wise. So I think, Rafael, what you're saying is the state machine by which you, today in case 2, when you push down keys, could be the same state machine as used for pushing down Diffie-Hellman keys, as opposed to our draft kind of implies a broadcast model by the controller. Is that right?
Yeah, the thing is, because you're sending the public key in a broadcast way, you mentioned, right?
Well,
but
it doesn't have to broadcast. A peer sends its public key to the controller only. All right, then the controller sends it out to all the other peers. How it sends it, whether it's in an individual message to each other peer, by the way, when you want to talk to Dave, here's his key, or whether it broadcasts it out as one big, here's Dave's key, that's protocol dependent. So we're not.
My comment, my previous comment was, of course, in some point, the controller needs to send IPsec security as an IPsec security association, inbound, outbound to the different two different NSFs, right? For example, for every key.
Correct.
So you're sending the information. What we are doing right now in case 2, we send all the information, including the key for the inbound and the key for the outbound. Okay. Right. So what we see is, okay, let's not send that session key, just send some key material, Diffie-Hellman key material, so the NSF just need to create the session key. So the session key is not seen by the security controller, but the security controller still has all the information about the IPsec security association except the key material that will be used in the inbound and outbound.
Correct. So a slight difference, though, to your state machine. You were talking about doing synchronization, sending out the inbound essays first and the outbound essays later. That would not be needed with this method. You could simply send out the essay information with the public keys, and the NSFs can then they can handle the synchronization of knowing how to install the inbound and waiting for the appropriate time to install the outbound.
You know, when we thought about that algorithm we have in our ID was, you know, to be pretty sure that we have the inbound first and then the outbound. So when the outbound is installed in the kernel, everything goes there. I mean, the flow will go using the new outbound, so the inbound in the other side will read it. But we also thought about saying, okay, here you have outbound or inbound to one NSF. Obviously, you will optimize the number of messages between the security controller and the NSF, because you're sending all the information, the outbound and inbound. But our approach, we consider that approach a little bit safer in the saying, okay, we have the inbound there, so nothing happened. The old one is still used. And then we install the outbound in the kernel, and then everything is reading both sides. But I mean, that algorithm can be adjusted. We also, as I mentioned, we also thought about installing outbound and inbound at the same time in parallel in both NSF. So we consider that as well.
Installing the inbound and outbound is going to break network communications, at least temporarily. You can't blindly install both. You need to keep things synchronized. Your method, I believe, will have scaling issues if you try to scale that up to, say, 10,000 nodes.
No, but the thing is, what you're negotiating is unicast security associations. It's unicast, which means you need a security association between this point and this point. Even if we have 1,000 nodes,
right?
But if this node has security association with different nodes, those are unicast security association. So it's one-to-one. So if something happened, for example, you receive expired notification from the NSF, from the kernel, actually, we are transforming that into notification using netconf and YAML model. The security controller will need to react, will need to install, maybe the policy has changed for some reason, and apply another different way in that particular moment. And then it needs to send the IPsec security association. The difference here is whether we send the session key from the security controller, meaning the security controller generates a random value, which is the session key, so the security controller sees that key, or we send a public key, Diffie-Hellman public key. We send that, and then the NSF will create the session key by its own, which is fine in terms of security, because the security controller doesn't see that key. But the procedure, all the information about the IPsec security association, all the policies, all the information is in the security controller. The security controller has the picture of the different nodes in the network. So to me, trying to move that, I'm talking about the case 2. So creating a state, NSF creates some state about the inbound, outbound. In our concept, the NSF in case 2 is even simpler. Everything is coming. All the configuration, IPsec configuration, is coming from the security controller. In terms of scalability, SDN paradigm is designed to support that kind of scalability. It can control many devices, routing information, now security. So I don't see a problem there. What I see, all the discussion here was we may have a security problem. The security controller may see those keys. And somehow this part feels people uncomfortable. And I understand that. We have that in security section part. Your idea is fine because solve that particular part. But not sure about what is the scalability problem, because in the end, the security controller needs to take actions based on events coming from the NSF for anything.
Okay. Well, I mean, at this point, maybe we should continue some of this offline.
Sure.
But I'm hearing what you're saying, and I think I have some comments to it, but I'd rather sort of beat it around.
Sure. Thank you.
Let's have a good discussion.
Thank you.
Thank you very much. Let's continue offline on the mailing list. So the next one, thank you. We are running a little bit late. So next one is the applicability document, and that's the one we actually, it's very close to working group last call. So, Paul? Yes, please.
Okay, we don't have enough time. I just quickly report the status and the remaining contents. Please take a look. So applicability I2NSF to network security services. This document updated. Added two sub sections. The first one is I2NSF with SFC architecture. The second one is I2NSF with NFV reference architecture. So the SFC case, we implemented the hackathon project. We proof of concept. Secondly, NFV reference architecture case, my university SKKU and then our colleague university, Sungshui University, we are working for implement I2NSF on top of NFV using OpenStack. So this coming November Bangkok meeting, we try to prove concept using hackathon project. So I mentioned, so mainly the applicability case, how to apply I2NSF to real network system. So you can see the three areas are addressed. The first one is the SDN with the I2NSF, other case SFC and NFV. Okay, so next, please, slide. So let me show you. So this is the structure for I2NSF with the SFC framework. So in order to we impose security policy into the traffic, we have to configure classifier or the service function forwarder with the traffic flow information and the security policy together. So that kind of information can be configured using NSF basic interface. Okay. So this is a detail. Let me skip it. And the last one is I2NSF with the NFV. So currently we're thinking security controller can be implemented using EM element management, and also developer management system can be also implemented as element management. And then the life cycling case, we just take advantage of existing NFV interface, VE and the VNF manager interface. Okay, Sean, go ahead. Yeah.
Thanks, Paul. On the previous slide with SFC, are you going to use NSH at all?
Oh, here?
Yeah.
Okay. So basically, we also using NSH. So we try to, for example, we consider one scenario is a chain of firewall and DPI or attack mitigation case. Especially firewall is the first NSF. If there is something, some message should be delivered to DPI, we can using NSH metadata filter, and then the next DPI NSF can take advantage of that. So we can surely use. Yeah.
Okay, that's good. I think you should maybe add an explanation in your draft on that. And then on the next slide, in a NFV system, especially a Manos system, you've called out one interface. Just ensure that it's obvious that that's a Mano interface, and I think there's some others that might be involved. So please take a look at the latest Mano drafts. I'm sure Diego can help you if you need some help there. And make sure that, because I think that Mano is established, so it's important that we are compatible with the Mano reference points. That doesn't mean that we don't need our own. Of course we do, but compatibility, I think, will be a big thing. Thank you.
Okay, thank you. Yeah. So Diego Lopez, also one of the authors, so he already gave us some information, open source Mano. So we definitely take a look. Okay, thank you. So we want to, last poll, we believe almost there. So welcome your feedback. Okay, that's it.
Thank you very much. And any questions? Actually, we are running out of time. So how about if you please read the document and provide feedback. We probably will call the last call after this meeting. So the next one is the capability information model.
Linda, just one thing, and this is Diego Lopez,
Okay.
Telefonica. Now, when it comes to the last call, Paul and I am talking about reshaping a little bit the flow of the document to make it a little bit more consistent and to tell a consistent story. So before we go for last call, just let me.
Okay, absolutely, absolutely.
And I'd like to help on the SFC side as well.
Okay, thank you. Thank you so much. You want to use this to control the page?
Sure, why not? I like lightsabers.
Uh-huh.
Hey, it works. So hello, my name's John Strassner, and I will talk about the current status of the capability model. This seems like it's...
Yeah.
Thank you. So who all has read the draft? Me, that's, this is kind of an important draft if we're going to do models. Please read it. Basically, a capability is a function or a set of functions that are advertised by an NSF. They can be vendor independent, they could possibly be vendor dependent as well. And with that, the security controller can realize the security functions desired for a given domain by putting together different capabilities from one or more NSFs. Normatively, we say that every NSF should be described with a set of its capabilities. Capabilities are not the same as access control, but capabilities may be affected by access control. So this draft defines an information model for representing capabilities in a vendor-neutral way. One data model implementation of that could be Yang. There's many others as well. There is the notion of a capability algebra. Now, what that algebra is a template to provide a mathematically formal definition of which capabilities are actually active. So if I'm the security controller and I have sets of capabilities from different NSFs, then using set theoretics, I can construct a algebraic definition, a template, if you will, of the final set of capabilities that are applicable for that NSF. That's very important because otherwise, not only do you not know what features are being used, but you have no idea if the policy rules conflict with each other. So this is a key part of the draft. So, thank you, Linda. Right now, the draft is restricted to imperative policies. So basically, when an event fires, if the condition of the policy is true, then you may execute actions, otherwise you do nothing. I say may because there's both metadata as well as other restrictions that control, for example, the execution order of policies. Remember, this is an imperative system, so order is important, right? You can also control side effects. So what happens if a policy fails? Do you continue executing other policies? Do you stop? Do you roll back? Etc. All of that is defined in the draft. There's a set of key abstractions. So the capabilities are independent of vendor, independent of physical or virtual implementation. You can, if you want, use metadata to add English-like descriptions. Linda's a big fan of English, for describing what this complex security mechanism is. So for example, this NSF can filter packets based upon source and destination address. Blah, blah, blah. I know you're behind schedule, so I'm going fast. Okay, so basically, scroll up just a little bit more. Okay, so this draft was built to be compatible with as many external projects as possible. So it does not define an information model from top to bottom, rather it defines a fragment, specifically two fragments. One for representing capabilities, which are a type of security, and the second for representing policy rules. And if the external information model doesn't have it, then a third fragment can define NSFs. So the way to read this is that starting with an external information model, you build an NSF object or set of objects. This funny little symbol is UML for an aggregation. So that means that the NSF may aggregate 0 or more security capabilities, which are inherited from metadata. This funny little symbol means an association class. So that means that I have the power of a class, attributes, methods, other relationships, etc., to realize the semantics of this association. So simple example, I have employers and employees. And let's assume that 0 or more employees can work for an employer, and an employer can have 0 or more employees. Where do you put the salary attribute? If I put it in the employee class, then every employer pays every employee that salary. That's bad. If I put it in the employer class, that's worse. If I put it in a association class, then the salary becomes an attribute of the relationship between employer and employee. And notice that this is now powerful. I can use that relationship to figure out raises, bonuses, etc. Same thing here with security. And well, we'll talk about Yang in a minute. So this is an example of a fairly complex industry standard. This is from the MEF. MCM stands for the MEF core model. And I've used these little highlights to show points where NSF could attach. So for example, in the MEF, we have not just imperative rules, we have declarative rules, we have intent rules, we have utility functions, we have lots of things. So this class says, I am a policy. This subclass here says, I am an ECA policy rule, simple inheritance. Any class can contain elements that are aggregated by it. So for an ECA class, you have events, conditions, and actions. So under policy structure component, you have a decorator, which I'll talk about in a minute. That decorator contains events, conditions, and actions. A decorator is a software concept. It was defined in 1995. It's used in pretty much every windowing toolkit I've ever come across. It's used in Java. And what it does is it allows you to use delegation to assemble a new object by putting all or parts of existing objects together. So think of it this way. If I want to extend functionality of a model and I create a new subclass, that subclass is not known to anything else. So I have to recompile, redeploy, do all the horrible things that operators hate. If instead I'm using the decorator model, I've already defined all my objects, right? Data is code, code is data. And so then all I have to do is to say, to make this new function, I want one of A, two of B, this part of C, add them together, and boom, I've got my new object, Sue.
Always love these general explanations, but I need to be tactical for a moment, John. Is it okay if I ask a tactical question, or should I wait till later?
No, fire
Okay.
away.
The tactical question is probably to ask you to provide your summation where you're heading for just a moment so I can get my mind into the right concept. We have the information model, and we have the data model. I'm at real peace, maybe you aren't, and that may be your summation, with having the information show all model for these capabilities, show these really cool ideas, and the data model over here have substantively less, because we can't really do all these cool things in Yang yet. They're making progress toward it, but they're not there yet. Is that why you're going to this explanation? You're telling us all the cool things, and then you're going to say something about it in the end? I'm just trying to make sure, and it's an essence of time. So I'm trying.
The answer is yes and no. So I would absolutely agree that any self-respecting data model would, at least should not, and possibly must not, contain everything that its parent information model has. That's like shipping a relational database in third normal form or higher. You have zero performance that way, in speaking generally, right?
Mhm.
And you have a whole bunch of things that your implementation might not use. That is not my quarrel. What I worry about is how we're constructing our Yang. You're absolutely right that Yang is not the best implementation language for policy. One reason that we're using association classes is to get around some of the limitations and semantics for Yang. And that's also why we're using the decorator pattern, to enable a more flexible construction of objects to get around these Yang problems. So the punchline is coming in the next couple of slides,
Okay.
where I'm going to give you some concrete recommendations, a recipe on how I would build the Yang to make it less fragile.
Okay, then I should probably have that debate with you once I see your recommendations.
Well, NMDA is adopting it, so we can debate it.
The NMDA?
Yep.
Of course. I'm off. You missed the channel where I'm really an NMDA proponent. So we'll wait till you finish.
I don't know. I fixated on debate, so I'm like, okay.
That's okay. I'll go back and wait. I just was missing the punchline. Now I know what it is. I'll wait. Thank
Okay.
you.
You're welcome. So any questions on this? So in summary, just in case people got confused, if I was building I2NSF in the MCM, which I happen to be, then for the event, condition, and action classes defined in our information model, they would subclass here under MCM policy event, policy condition, and policy action. If I was defining metadata to better explain policy or other objects, they would subclass, where did metadata go? Metadata isn't shown on this one, but it's probably about right there. They would subclass from the MCM metadata class. Our I2NSF security rule is a subclass from MCM ECA policy rule. So just as I said in answer to Sue's question, do I have to use all of the structure? No, but if I want to, I can. That's the advantage of building a modular object-oriented info model. Okay, so now the Yang. So for me, as an object-oriented guy, there's three important things that an object-oriented model must provide. One is the concept of class. Two is the concept of inheritance or subclassing, if you will. And three are relationships. Now, Yang cannot really differentiate between an association, an aggregation, and a composition. And that's fine. But we can still build relationships in Yang, and we can get around that problem by implementing every relationship as an association class. So in our model, that's exactly what we've done. If we have a relationship, it is always implemented as an association class. That makes coding and implementation for Pulse students much easier. Now, when we build a class, and this is a summary from the work that we did in SUPA. So what we do is we use an identity and a grouping. Why? Well, how else can you tell whose parent this current Yang leaf is? Right? So every class has a grouping. Every grouping has one leaf that has a unique system-wide identifier that identifies this instance, and then the second leaf is just an identity ref. And what that allows you to do is a very simple form of reflection. Now, and translated, for those of you that aren't software implementers, that means that I can always determine the type of object that is on each end of the association. If you don't do this, I do not understand how you can guarantee that either end of the association is what you think it is. So I think this is something that the data models haven't done so far, and I would strongly encourage you to do this. And if, for those of you that are implementing, if you don't understand this, then let's discuss offline. Subclassing uses a similar approach, and we did this specifically to simplify coding. And so now we've got identity and a grouping, and the important thing here is that we're using inheritance of the identity itself to emulate the subclassing that we do in the model. Because remember, Yang is a flat model, right? Yang, you cannot represent hierarchies of hierarchies unless you do special things. This is one of the special things. The third point is associations. These are a little more complex, and again, if you want to talk to me, I'm making myself available. But what we do is basically combine the first two steps. So we define a new class that represents the association class. We use instance identifiers for each end of the association and the association class. And then we have instance identifiers that basically point from the source to the association class and from the association class to the destination. It's very simple to implement as a software pattern, and it will make your life easier. I can skip the rest of this since we're out of time. And this is just an example of what something like this would look like following these rules. When you see PTR, that's just an instance identifier that is implementing one end of an association between an object and the association class. Sue.
So, good explanation for everyone. I did mention it to the other co-authors. We needed to be NMDA compliant because we won't get through the Yang doctors without it. Some of these are really good suggestions. Thank you, John, for presenting.
You're welcome. And if I can help you guys in implementation, I'm an email away. That's it. Any questions? Questions from a co-author is usually bad.
No, it's just like,
Okay.
not to,
Well, don't scare me.
to question anything, no. No, I have come to the idea that we should try to find a way in which we could create some kind of actionable mapping between this and the other data models that are around, so we can allow them to refer to capabilities inside. And this is the only thing. That's just to, we have had no time to talk about this because it has been complicated. But this is something basically for our chair to know that we are looking at this.
Thank you so much. And we definitely need to align the two. Maybe afterwards we should have an offline, maybe conference call to resolve that.
Because just at the end I'm chairing another meeting.
Okay, yes.
It's going to be challenging.
We are running out of time, and so I'm so sorry for getting too much time onto that IPsec thing, because that's really important for many of the SD1 deployment. So now we only have time to do the data model. Yeah. So the data model actually is a very important deliverable from this working group.
This is Paul Jung from SKKU Korea. So shortly, I can report my group tried to address the John and the Frank information model to our data Yang model. So almost, stuff I believe reflected, but we tried to more our Yang model looks like object-oriented using identity John mentioned. So my team tried to finalize. So let me shortly because we don't have time, so scroll down. So you can see data model, our working group case capability. This is SUS, the base Yang model. Based on that, we made the consuming facing, NSF facing, restoration. Also monitoring, also the Frank is working for information model. So this is very important to monitor the NSF, okay? So we implement all of them during hackathon project. So we prove concept, we try to make finalize. So currently the restoration and the monitoring model I will also try to working group adoption code, okay, this time. So last slide, I believe just the update, so you can take a look, and if you have question, please let us know by the email, okay? Frank, do you have a question or comment? No, okay. Okay, so, okay, go ahead, yeah.
In wisdom, Linda, this is where I want to put the other slide I sent you.
Yes. Okay.
I instead of just having a mic comment on this, I realized this in the middle of reviewing this with the co-authors, so I sent a slide. I tried to be effective. Okay. And you notice it's not in the form of a draft, so you know it's just a to-do, it's a discussion point. You can go to the next slide, Linda. Okay, look, when we were looking at it, we started to talk, where's the operational state for the data model? We've talked about really cool capabilities, but you've not talked about where the operational state, where the NSF address and the transport. It's not really applicable to put it in the registration. I think Diego made that point. That's what you get from vendors. It probably needs to be in some place toward the NSF nodes. It's probably not just straight a capability, but it's an operational issue you need. You need to know, here I am a controller, I need to know what the NSF address is, I need to know how to transport. Paul has put this, and his wonderful hackathon team has put that in their actual implementation, so it works. It's just a to-do. It needs to be stored someplace, and I didn't want us to forget it because it's operationally needed. So that's my short.
Okay, so my team, we will address this in one solution is a registration interface, maybe can, okay. Okay.
So those data you're saying to be put into the registration data model? Okay. Okay, so we have time, probably do one more, the information model. Okay.
Hi, this is Seung-Jun Wee from SKKU, and today I explain updates of the two information model of the I2NSF. So for the console-facing interface, we added the role-based access control section in order to synchronize the requirement of console-facing interface IAM. And the description of condition graphs is consisting the condition object is added, and we also added the diagrams representing the high-level abstraction of console-facing interface, condition graphs, role-based access control, and the other objects consisting the IAM. And for the next steps, we will request the working group adoption call, and we will expand the object in depth to cover some popular security service such as firewall, web filter, and DDoS authentication. Also, we will apply the semantics used in a condition class to the event and action sub model. So, and registration interface. First, we revised the section 4 to discuss about updating on existing NSF instance via the registration interface. According to the changes, the figures 2, 3, and 4 have been updated. We also clarified the Appendix A to discuss the use of the registration interface related to the lifecycle management. So for the next steps, we will request the working group adoption course for the registration interface 2, and we will implement instantiation, de-instantiation, and updating functions through the registration interface in the OpenStack and the OpenStack open source manual environment.
This is something I have, probably I have repeated this since we first saw these information models. I believe that we should not have separate information models documents, with the exception of the capability model, and basically because the capability model implies complex algebra for generating policies and translation. I think that to me it makes sense to have this as an introductory discussion in the corresponding data model documents. I have seen this, I have said this several times, and I will repeat myself as many times as necessary.
I'm sorry, you're saying those should be included in where?
My point is that I don't see the need for having separate information model documents.
Okay.
With the exception of the capability model, because that defines a complex a little bit more complicated algebra for capability matching and all the like. So I believe these documents should be an introductory part of the corresponding data models.
I see. Thank you.
So this is Paul from SKKU. So I have a different opinion. The current consumer-facing interface information model and restoration case address the aspect of consumer-facing and the restoration. So current capability information is very good, but specifically different the interface case. I still believe that the separate information model also valuable. So we try to parallel the working group document will be helpful for data model. Okay.
Got it. So in the interest of time, we are running out of time. There's a remote anticipation presentation. So maybe you can just spend 5 minutes to discuss that. So Diego, I remember when we discussed this last meeting, and Kathleen said they're going to create a new initiative in IETF to do that. Okay. Yeah.
First of all, let me insist, replying to Paul, I'm not saying to build a single information model document. What I'm saying is to bring the different information models to the justification of the data models. Okay. What I'm saying is that is to take the text of the registration interface information model to the registration interface data model as part, merging IMs and DMs one by one.
Got it.
When it comes to the attestation, that's just to the document we have added to the document we have added some sections on topology attestation, which is important thing. And please have a look at it because it's something that is connected with some ideas we are going to discuss in SFC, which is about well, I should go the other way.
Oh, okay.
To feel that I am on the in control. So well, that just to go very fast. What's new is precisely this: is about having topology verification mechanisms, topology attestation mechanisms, including a proof of transit using an SFC verifier. Have a look at it. Have a look at the proof of transit document in the SFC group. And the important thing here is that take into account, we're not talking about, Kathleen was mentioning this is not a general document on attestation. This particular one is very much oriented to I2NSF, is very much connected to the idea of having the security controller as the point collecting the measurements of all the components, delivering it to the client for further verification. So it is a particular it's a particularization of a general attestation flow for the case of the I2NSF environment. So we believe it belongs here. If for whatever the reason the group doesn't think that it belongs here, well, we will stop working on this and we'll concentrate in the general flow. And maybe in the future we will put as part of another document. In the case of I2NSF, blah, blah, blah. And this is why, well, it's a call for adoption, or let's forget about this. Okay. And finally, just if you allow me, tomorrow at 7, I'll share with you the announcement again. We will have a bar, this informal side meeting, whatever you call it, to discuss precisely about the possibility of starting some activity regarding general attestation inside the.
So this is more about monitoring the secure environment of the NSF. Is that what you're saying?
This is about the idea is that it relies on the architecture that we have with the security controllers and the NSFs. So it performs or it proposes mechanisms for performing attestation based on the fact that you have a controller that is centralizing everything.
Okay, thank you.
Comments? Diego, I agree that this is very closely to the I2NSF architecture, based on that architecture to do the remote attestation. So maybe we can do this in I2NSF working group. But I think we should be careful that we will have another remote attestation initial work other place, right? other work. So how to align your work with those work? Because in the finally, maybe we will share the same protocol, the same process. So we don't hope that there are some confliction between here and there. So yeah.
Frank, I'm not saying that we go for last call or whatever. What I'm saying is that whether is to check whether the group is interested in continuing this. Maybe this will even happen that we close the group and it's not finished because it's not aligned. Yeah, but if you I mean, I'm asking whether the group believes that there is a value and that we continue working for this here. If not, well, we can make a particular case or whatever. It's simply that.
Okay.
No, for sure. It's not. I'm not asking to go and publish this yet.
Because I think it should be here. So I say that maybe later we will need to be aligned among those works.
Sure.
Okay, thank you very, very much. I'm sorry for 2 more drafts we didn't finish. Yeah, where's the blue sheet? Can people pass around? And if you haven't signed your name, please do. In the back table, so please go sign it up. Thank you very much. And I think we have 2 more drafts didn't finish, so we can continue the discussion. Your draft probably is more part of the data model, right? So please working with the data model authors, see if you can incorporate that into their drafts so we can finish our I2NSF on time. Thank you very much.
So okay, let me, just 1 second. So we implement the security translator. Please read and give me comment by email. Thank you.
Thank you. Thank you. Thank you very much. Oh, okay.